In this lesson, I'm going to show you how to work with complex numbers. Complex numbers are numbers that have the real as well as an imaginary number together. I'm going to show you how to add, subtract, multiply, and divide, or simplify a fraction with complex number in the denominator. So let's begin with adding complex numbers. When you're adding, you simply have to go ahead and add the real with the real. 3 plus 6 is 9. And we're going to add the imaginary number with the imaginary number, meaning the I with the negative 2i. When you add I with the negative 2i, we get minus I. Next, I'm going to show you how to subtract. When subtracting, we need to go ahead and take that negative, apply to the 4, and also the negative 3i, where it's going to be this. Once again, we're going to combine the real with the real. 8 and the minus 4, we get a 4. And if we combine the negative 6i with the 3i, we get negative 3i. Next, let's go ahead and try multiplying complex numbers. We're going to FOIL, meaning we'll take the front with the front. That's where the F for the FOIL comes in. Negative 5 times negative 2 is positive 10. Next, we're going to multiply the outer one. The first one with the outer one, so that's where the O comes in. So negative 5 times the positive 2i, which will be negative 10i. And then we're going to multiply the inner, meaning the inside ones. Negative I times, that's where the I comes in. Negative I times 2 will give us positive 2i. And then we're going to multiply the two last ones for L. The negative I and the positive 2i, which will give us negative 2i squared. Then we're going to simplify the negative 10i plus 2i into negative 8i. And also, remember, since I is square root of negative 1, I square is negative 1. So instead of that I square, we'll replace that with negative 1, where negative 2 times negative 1 is positive 2. And then if we add the 10 and the 2, we get 12 minus 8i as our final simplification or product of negative 5 minus I times negative 2 plus 2i. Let's do one more of multiplying complex numbers. Here we're given 2 minus 3i root 2 quantity squared. So let's go ahead and rewrite that as and we're going to do the same thing here, meaning FOIL. So we'll take the 2 times 2. 2 times negative 3i root 2 will be negative 6i root 2 because 2 times 3 is 6. And then we'll multiply the inside, which will once again give us 3 times 2 will be negative 6i root 2. And then the last one is the one that's a little bit more tricky, meaning the negative 3i root 2 times negative 3i root 2 is going to be negative 3 times negative 3 is plus 9. And then I times I is I squared. And root 2 times root 2 is going to be 2. Hopefully, you're okay with that. Next, let's go ahead and combine the negative 6i root 2 with negative 6i root 2, which will be negative 12i root 2. And here I'm not going to do much. I'm just going to change that I square into negative 1. Nine times negative 1 times 2 is negative 18. And then lastly, 4 minus 18 is going to be negative 14. And then we have that negative 12i root 2. So there you have, folks. We did the adding complex numbers, subtracting complex numbers, multiplying complex numbers, and also another example of multiplying complex numbers. Now let me show you how to go ahead and simplify a fraction with a complex number in the denominator using the conjugate. Here we have a fraction where we have a complex number in the numerator as well as the denominator. In most cases, a problem will ask you to remove the complex number from the denominator or make it so that you don't have an I on the bottom. In order to do that, you want to multiply the numerator and the denominator by the conjugate of the denominator. Meaning, we'll take what's on the bottom, multiply by the same real number, however, the opposite sign of the imaginary number. Since we have a positive I here, we need to go ahead and change that into minus I. So if we have a 5 plus I, we want to multiply by its conjugate, again, which is 5 minus I. And of course, if you multiply by 5 minus I in the denominator, we have to go ahead and multiply by 5 minus I in the numerator. So let's go ahead and multiply these two fractions. First, 3 times 5 will be 15. 3 times negative I will be minus 3i. 2i times 5 will be positive 10i. And 2i times negative I will be negative 2i squared. The denominator, 5 times 5, 25. 5 times I minus 5i plus I times 5 plus 5i. And then lastly, I times negative I will be minus I squared. As you can see, that negative 5i and the positive 5i will cancel each other out, leaving us with just the 25 minus I squared. In this case, you want to remember this. Given x plus y times x minus y, notice that the numbers are same, however, the signs are opposite of each other, then you get x squared minus y squared. So the product of two binomials where we have the opposite signs will always be x squared minus y squared. Meaning if we have 5 and plus I minus I, without even multiplying this out 4 times, only thing you really have to do is 5 times 5, which is 25. And then the I times negative I, which is negative I squared. That would be the shortcut. Let's continue by simplifying the numerator, where we get negative 3i and 10i will give us that positive 7i. And remember that I squared is negative 1. So negative 1 times negative 2 will give us that positive 2. On the bottom, we have 25 minus I squared, which is negative 1. And our final answer will be 15 plus 2 is 17. 25 minus a negative 1 will be 26. And that will be our answer. If you want to take one extra step and rewrite this as two separate fractions, you could rewrite it as 17 over 26 plus 7 over 26i. So there you have it. So the key is take the original denominator, multiply by its conjugate, and then multiply the same thing on the numerator and simplify. Let's do one more just to make sure. Here's another example of a fraction that has a complex number in the numerator and also the denominator. just like we did in our other example, I'm going to be multiplying the denominator by its conjugate. Again, the 2 doesn't change. We're going to multiply by the opposite of negative 3i, which is plus 3i. If I multiply the bottom by 2 plus 3i, we most certainly have to multiply the top by 2 plus 3i also. 2 times 2 is 4. 2 times 3i, we get 6i. 5i times 2, 10i. And then lastly, 5i times 3i, we get 15i squared. For the denominator, I'm going to be using the rule that I just showed you, where all we have to do is 2 times 2, which is 4. And I'm not going to go ahead and multiply the 2 and the 3i or the negative 3i and the 2 since they're going to cancel out anyways. Only thing I'm going to multiply is the negative 3i and the positive 3i, which will be negative 9i squared. We want to save time whenever possible, which equals 6i and 10i is our 16i. And then 15i squared is 15 times negative 1. So it's going to be negative 15. Same thing on the bottom. That I squared turns into negative 1. 4 minus 15 is negative 11. And then we have the 16i. On the bottom, we have 4 minus 9 times negative 1, where negative 9 times negative 1 is positive 9. Add that to a 14, we get 13. And again, if you want to separate this into two fractions, it would be 16 over 13 I. So I hope you like this lesson and benefit from it as well in how to add, subtract, and multiply and simplify a fraction with a complex number in the denominator.